Dear students, how are you? So let's discuss science problem from TOLC-I exam. This is the practice materials I have been following last couple of weeks. Okay, so this is our problem number 31, and you know, like from science problem there will be 31 to 40, in total 10 problems. Okay, mostly from physics. So let's start. Two bodies A and B have the same volume and masses. So masses are given here. A given relationship is this: mb equal to 3ma. Both bodies are completely immersed in a liquid. So liquid, we don't know, it could be water, it could be oil, or any kind of, and are initially held still. When they are let go, the buoyant force exerted by the liquid 1b is, okay, we have to find out the relationship. Okay, for example, equal to the buoyant force exerted 1a 9 times the force exerted 1a. So I'm not reading rest of the options, you can just read it. So let's take a look on this picture. So it's given that both objects or both bodies has same volume. Okay, so that means we can write volume of A equal to volume of B. Okay, that means amount of liquid or amount of water, for say, removed by these two bodies are the same. Okay, as they are immersed inside into this liquid, that means the amount of liquid removed by these two objects are exactly the same, and that doesn't depend on the masses. Okay, although we know that here ma actually lightweight and mb is 3 times heavier than ma. Even though it's heavier, but it doesn't affect the removal of masses of liquid. Therefore the buoyant force would be same. And now what is buoyant force? Actually, buoyant force is something that if you remove these two objects, or if you remove the force, okay, if you remove your hand, then there will be a force, right? Because of that force, this object will feel a force upwards, and that is called buoyant force. So this buoyant force will be exactly same, because the amount of liquid removed by these two objects are the same. So our answer is A. So this is problem number 32. Let's read it out. A body of weight P placed close to the earth's surface is let fall from the rest. Let G be the gravitational acceleration and let the air resistance be negligible. Then the kinetics energy possessed by the body after t second is, okay, so let's consider a objects. For example, it could be any objects, like we can name it a box, which is actually placed close to the earth subject. This is earth and this is our earth subject. So this object actually it's held here. Okay, so now if this object let go, then because of gravitational force, we know that center of the earth has a gravitational force, and that gravitational acceleration is g. Okay, because of this g value, this object will tend to come down, it will travel on the surface. So now we have to find out the kinetic energy possessed by the body after t second, after time, for example t. So this is basic question of physics, like basic formula okay, basic theorem of kinetic energy. And we know a theorem like if the object mass is m, then after t time half m g t square. This is the basic formula. So the weight of the object here is given by p, okay. So therefore our answer is half p gt square, option B. A pipe with constant cross-sectional area S is bent into a U shape. Okay, let's take a look here. So this is a pipe and it has a cross section S, okay. So one side of the pipe is open whereas the other one is closed by the cap T. So here this is the cap T. So this side is closed by this cap and other side is open. The pipe is filled with water and water density given by rho, okay, that reaches height h and h in a small letter in the two arms. So that means height of the open arm is h and height of the closed arm is smaller h. The force that water exerts on T is equal to, so the water will force this T upward direction. Why? Because if you take a look here, if you just level it, then you will see the water level is higher here, right? So this amount of water will give a force in downward direction, but this water level here will give upward force, okay, buoyant force. We have to find out the amount of force and the direction. So we already know the direction will be upward on the T, but what would be the amount of force? So if we just calculate the weight of this area, the water is occupied by this area, so weight of the water would be this equal to the force. We have to find out that. So first of all, let's find out the volume of this area. So we can write volume in terms of V, and we know the height of this is very simple, like we can just minus a smaller h from the capital H, then we'll get the height. And we know the cross section, that means the area of a unit area, that is called cross section, and that is S. So you can just multiply it. So this is our volume. Now if we multiply this volume by rho, then we'll get the water content here. So we can simply just multiply volume by rho, then we'll get H minus S and rho. Okay, so we got the amount of water here. Now what would be the force? We know in general F equal to mg. Okay, so in that case we got the amount of water which is mass m, and we know the gravitational acceleration will act here, therefore we can just multiply by g is rho, and we can write g here. So our force will be upwards. So our answer is option E. Okay, so it's very simple. If you still do not understand or if you have any confusion, just let me know. It's I think it's a very easy and basic question, but you have to visualize the problem very well. You have to read out, and I always suggest you to mark the words that you don't know, like the basic stuff like cross-sectional area or other terminology. Just note them and try to memorize. A heat engine has 75% efficiency, that means efficiency is given 75%. Okay, how much heat is absorbed during a full cycle if the total work produced by the engine is equal to 3.6 kilojoule? So we know the this basic formula, the efficiency E equal to the work W, and Q is absorbed heat that we have to find out, and 100 multiplied by 100. You can write it a different way, like simply E equal to W by Q. This way also you can write, you don't need to multiply by 100. In this case you have to consider putting the value of 0.75, not the 75%. However, we wrote it in this way, so this is our equation, E equal to W by Q multiplied by 100, and efficiency is given 75%, and work is produced 3.6 kilojoule, and Q is the absorbed heat that we have to find out, so it's like 4.8 kilojoule. So our answer is B. In the periodic table, chemical elements are ordered by number of protons, alphabetic order, abundance in the universe, size, year of discovery, and all we know the answer is A. It's very basic questions. Sound is, so in this problem we have to find out the definition of sound. So if you know the basics, then this is not a difficult question, so we can just opt out the wrong answer. For example, if we take a look here, this cannot be a speed of sound, is too much, you know, the wave that propagates in an elastic medium at a speed of, so sound speed is, we know, like 340 meter per second, so we can just opt out, or similar way we can opt out this one. The rest of three options could be the answer. Let's read it out. A wave that propagates in an elastic medium with a speed that depends on the medium itself. Yeah, that seems logical. It could be answer because we know the sound actually propagates in vacuum medium, in vacuum, when it's like we can consider a empty space. In that case the speed is 340 meter per second, but it depends on the type of medium. For example, if it is iron or water, then the sound would propagate faster in iron. Okay, in water it would be less than iron but higher than vacuum. So this seems correct. Okay, let's read option B. An elastic wave that propagates in vacuum at a speed of 340 meter per second. Yeah, this is correct statement, but you have to think that this seems more close to correct because they gave more information than this. Okay, in this case, yeah, in vacuum at a speed of 340 meter per second, that's correct, but it depends on different medium. A wave that propagates in a vacuum and all materials medium at a speed of 340 meter per second. This is not correct because already I told you that the speed of sound is dependent on the medium itself. You mix 60 liters of water at 20 degrees centigrade with 20 liters of water at 60 degrees centigrade. Neglecting heat dispersion, the final temperature reached is, so okay, you are mixing two bottles of water. One bottle has 60 liter but temperature is 20. Another bottle has 20 liter but the temperature is 60. Now if you mix them, then what would be the final temperature? So if we consider this is T1, this is T2, and this is T3, then we have to find out the final temperature. And we can consider this is M1, this is M2, okay, and our final mass M3 equal to 60 liter plus 20 liter, overall 80 liter. Now we can write the formula. So this is the formula, M1 T1 plus M2 T2 equal to M3 T3. So our final multiplication of masses and temperature will be equal to the two cases, the summation of two cases. So if you just input the values, 60 mass of first cases, the temperature of first cases, then mass of second cases and temperature of second cases, and this is the overall weight of the liquid, and this is temperature, then you can find T3 equal to 30 degrees centigrade. So our answer is D option. Two metallic spheres A and B are suspended from the ceiling by insulating wires. A positively charged glass rod is first brought near A, then near B without touching them. We observe that A is attracted to the rod, whereas B is repelled by it. Therefore, we can infer that. So, infer means we can conclude or we can deduce that. So, let's understand the problem first. Two metallic spheres A and B. For example, this is the metallic spheres A and B, and a positively charged rod is given here. So if you bring them close to the sphere surface, then in the question it is said that A actually attracted by the rod, that means A has negative charge, and B is repelled by it, that means B has positive charge. So our answer is E. Let dot represents the scalar product and X the vector product. Which of the following operations gives the magnitude of the projection of vector A on vector B? So for example, this is vector A and this is vector B, okay. And from the basic definition of vectors, we know the projection of vector A on the B would be the multiply of vector A with the unit vector of B. So we know the unit vector actually vector V divided by its magnitude. Therefore, our answer is E. A train travels at a speed of 144 km per hour. That means these trains travel this amount of distance, 144 km in 1 hour, okay. We can just label it like that. Its wheels perfectly adhere to the rails, no sliding, and have a diameter d equal to 80 centimeter. So for example, this is the wheels of trains and it has a diameter 80 centimeter, okay. So this is the diameter 80 centimeter. So if diameter is 80, that means radius is 40, okay, 40 centimeter. How many turns do they do in 1 second roughly? So if this wheels turns one time, that means it travels equal to its circumference, that means the distance around it, okay, equal to circumference. And we know the formula, circumference C equal to 2 pi r. So here 2 pi and r equal to 40, so 80 centimeter. So per turns the train goes 80 centimeter, okay, for example this amount of distance. But we know in 1 hour it goes 144 kilometer per hour. So what we can do, in 1 hour how many turns the wheels do, we can find out just dividing the distance 144 divided by 80. But remember, here it's given kilometer, so we have to convert it to centimeter. So to do that, or simply we can convert this circumference into the kilometer. In that case we can just multiply, oh I missed that, 80 centimeter equal and then pi, there is pi as well, we have to consider that. So what we can do here, we can simply divide it 80 centimeter, 80 pi centimeter divided by 100, then it's meter, and if we divide again, we know on 1000 meter equal to 1 kilometer, then we get the distance in kilometer. So it becomes 0. So if we multiply 80 pi centimeter, 80 pi centimeter divided by 100, then it becomes in meter, okay, in meter scale. So we can write it like 0.8 pi meter. Now what we can write here, now think, so per hour it goes 144 kilometer. So if we divide by 144 kilometer, we can make it meter, and if we divide the circumference distance 0.8 pi m, then what we'll get, we'll get rotation per hour. That means per hour how many times the wheels are sliding, not sliding, sorry, wheels are turning. So this is rotation per hour, and if we multiply this value divided by, not multiply, if we just divide again by the time second, because we know 1 hour equal to 3600 second, therefore we get 15.91 rpm, rotation per second, because our answer have to be in second. So we find out the rotation is close to 16 rps. Our answer is E. So this was today's problem, today's tutorial. If you have any questions, just let me know. I will try to solve, I will try to give you more insights into it, and let me know what kind of questions do you want in future. Maybe I will try to explain you some problems from TOLC-E, and if I have time I will also cover reading comprehension. So stay with me and please subscribe and share with your friends. Have a good time.